Hey guys, so I recorded a video and it got deleted, so we're going to carry on from the last one right here. This is already all filled out. We ended up the last one, we calculated the total circuit current right here, and now we're going to calculate the impedance, and the only way to calculate the impedance on a parallel circuit is using Ohm's law. It is going to use the voltage that I dreamt up divided by the current that I calculated using that voltage. Okay, so Z is going to be ET total over I. It is going to be 100 over 34.36. If you do that math, you will see that it is 2.91 ohms. Now, that is the only way to do a parallel circuit. There is only one legitimate current phasor diagram for a parallel circuit, and that is a current phasor diagram. There is no such thing as an impedance phasor diagram, and just for fun I tried it here just to see if it would work. I put 3 on the bottom, okay? I went 6 up, I went 4 down, X here would have been 2, and then if you calculate the Z using 3 squared plus 2 squared square root, you get 3.6 ohms, which is wrong because the actual impedance of this circuit is 2.91 ohms. There is no impedance phasor diagram for this circuit. It would be like thinking this was 95 ohms. Okay, 50 plus 25 plus 20. It ain't. It's 9.09 ohms. Okay, but the total current is the sum of the currents, and RTZ can be calculated using E total over, the total, the sum of all the gadgets in the circuit that limit current. Okay, so it's Z is equal to E over I. No. Forget what I said about there, okay? Ohm's law, that's how you calculate the impedance of a phasor, of a parallel circuit. So don't do this, it won't work. Now, the phase angle, you can see it right here. It is going to be, well, there's the total circuit current, guys. There's the voltage, this blue line that I, compared everything to. And you can see the phase angle right there. It is going to be opposite over adjacent, inverse tan. I did it right there. 8.33 over 33.33 inverse tan, it's 14.03 degrees, okay? And you can't use this phasor diagram to calculate that either, because that would be also wrong. All right, guys? Now, let's look at the leading or lagging here, because that can be confusing. Just like the series circuit, I have to do it the same way. I have to identify the current phasor and to decide if it is counterclockwise or clockwise from the voltage phasor. Now in this case, the voltage phasor is the horizontal line. On a series circuit, the current was the horizontal line. So when you were looking at a series circuit, you were trying to find the horizontal line. Okay, here's one right here. Okay, on this one, we identified the current phasor. We noticed it was clockwise. That is why it was lagging. On this one, we are going to identify the current phasor. It will be the hypotenuse on this particular, on any parallel circuit. I'm going to decide if it is clockwise or counterclockwise from the voltage. It is counterclockwise, which means it is leading. All right, guys? So you calculate or you decide whether it is leading or lagging the same way you do a series circuit. Identify the current phasor. Decide if it is clockwise or counterclockwise from the voltage phasor. And it is counterclockwise. All right, guys? So that is how a parallel circuit gets done. I'm going to do another one in the next video. It'll be number 2 from the handout, Unit 4, Handout 5A, number 2. Tune in a couple of minutes and we'll check it out. All right, guys?